question is from GATE 2015 Mechanical Engineering paper, set 2, question number 32. For the truss shown in the figure, the magnitude of force in kilonewton in the member SR is. Now here we have to find the force in member SR. At joint S, if we consider where the load is acting, if we directly consider the joint S to calculate this load, there are 4 number of unknowns at joint S, and that is why we cannot solve this. So we will have to consider another end to find this force, that is end R. At R, we have 3 unknowns from which this unknown FRQ, force in RQ, can be found out using the reaction at Q. So we'll start by finding out the reactions first. First thing, summation of vertical forces in the truss overall will be equal to 0. So we can write RP plus RQ. We can assume RP and RQ upwards. So they will be positive, will be equal to the downward load 30 kilonewton. If we take summation of moment about P at is 0, we can have the moment created by 30 kilonewton clockwise moment. So we can take it minus 30 into the distance is 2 meters plus RQ is creating an anti-clockwise moment. So RQ into 3 meters is equal to 0. From here we'll directly get the value of RQ as minus 60 goes to the right hand side becomes plus 60 by 3, that is 20 kilonewton. The load is in kilonewton, we'll get the reaction in kilonewton itself. Now we know that this reaction RQ is 20 kilonewton. At this particular joint Q, there are two perfectly vertical forces opposing each other. So this force in RQ will be equal to the reaction RQ, and the horizontal member will have a 0 force. So TQ being a 0 force member RQ will have the force equal to reaction RQ. So this is upward, we will have to have a reaction downward. We'll have to have the force towards the joint. So the force is towards the joint, that is compressive. We have force along with the reaction. We also have force in member RQ is equal to 20 kilonewton. But because this is downward, this will be negative minus 20 kilonewton. Let's construct the joint free body diagram for R, for joint R. Let this as the joint R. We have one known force here, which is of 20 kilonewton, upward 20 kilonewton. Now we can consider the forces in SR and TR be away from the joint. Let the unknowns be FSR and FTR, and let these be away from the joint first. Whatever the signs comes out to be will give us the direction. This angle is 45 degrees because the horizontal and the vertical side both are 1 meter equal to each other. So we have the 45 degree angle here as well as here. Let's write the joint equilibrium equations now. For the second part, we have at joint R, the known force is vertical. So we'll start with vertical. Summation Fy at R is equal to 0. We have an upward force of 20 kilonewton. So it is positive. FTR has an adjacent component downward. So we can write minus FTR cos 45. Cos 45 degrees is equal to 0. There is no other force at joint R which has any vertical component. So this is our equation. We can find out FTR using this. FTR is equal to 20 by cos 45. So we have 20 by 1 by root 2, which is nothing but 20 root 2. This has come out to be positive. So this direction that we assumed is correct, and magnitude is 20 root 2 kilonewton. Now we know FTR also. We can use summation F of x, that is forces in x direction, at R is equal to 0. Of course, we have considered x as the horizontal and y as the vertical direction. This is understood because reactions are also calculated in the same way. So at R, if we consider the horizontal forces, we have FSR in the negative direction. So we can write minus FSR. Another force is again the component of FTR in horizontal direction, which we can write minus FTR, either sine 45 or cos 45, both are equal. So we can write sine 45 degrees is equal to 0. FTR is known. Let's put the value and find out FSR. So FSR taken to right hand side, again written on left hand side. FSR is equal to minus of 20 root 2 into sine 45 is 1 by root 2. Root 2 by root 2 giving us 1. We get the answer as minus 20 kilonewton. So the sign that we assumed was wrong, or actual force is opposite to what we assumed, and hence it will be towards the joint. So we have force in member SR is a compressive force, that is towards the joint R. Let's mark the answer. Magnitude of force in kilonewton in the member SR is a compressive 20 kilonewton force, option C. Of course, in kilonewton is already mentioned. To learn more about trusses and forces in truss members, you can refer to the NPTEL video, Lecture 7, Trusses 1, from the course Engineering Mechanics by Professor K. Ramesh. He is from Department of Applied Mechanics, IIT Madras. I hope this solution will help you clear your doubt regarding this question. Thank you.